In the previous video, we went through all the necessary theoretical background. Now we are ready to start an example problem, and here's a nice one. Answer the following questions regarding the original function f of x, while the graph of its derivative function is given below. This blue graph is the derivative. I am using the color coding. Red is the original function here, and all the questions here are asking about the red function, or the original function. That graph is not provided here. The derivative function is here. Okay, how about A? Find the intervals in which the original function increases and decreases. If you blindly look at the derivative function, and then if you write like this, decreases in the interval negative infinity to -1, increases in -1 to +1.5, about 1.5 right here, decreases in 1.5 to about 3, increases from 3 to infinity. If you write like this, you just earned automatic 0 credit because you answered everything based upon the derivative function. It decreases from -infinity down to -1, all right? Got it right. -1 to -1.5 increasing, that too is correct. 1.5 to 3 decreases, good. 3 to infinity increases. Everything is correct except that all this is correct with respect to f prime, while this problem is asking you about f. So this is automatic 0 credit. How about the second problem? Find the x-coordinates of all critical points of the original function and describe its nature, local maximum, local minimum, or neither. You may say local minimum right here, x equals to -1, local maximum at x equals 1.5, local minimum there, x equals to 3. If you write like that, again, it's automatic 0 credit. Same reason. You answered correctly with respect to f prime, but that's not correct because this problem is about f, not f prime. So how do we do it? Let's go to the solution. Here we go, and let me copy and paste this graph. Okay. Let's consider this diagram. How did I get this diagram? X equals -3. That's where the graph of that derivative function hits the x-axis. That's when the derivative hits 0. That's a critical point. X-coordinate of the critical point is x equal to -3. Next, x equal to 0. That's when this derivative hits 0. It hits 0 once more right here at x equal to 3. So these 3 are critical points, or the x-coordinate of the critical points. Now, these 3 critical points, -3, 0, and +3, divide a number line in 4 pieces. Less than -3, so left-hand side over here, and between -3 and 0, in between over here, and between 0 and 3, and then finally, greater than 3 is right over here. Look at the graph. Look at the derivative function, and the derivative f prime is positive above the x-axis when x equals to -3. Here, my mouse is right over there. It's above the x-axis. That's plus. Between -3 and 0, below the x-axis. So f prime is negative. From here to there, negative all the way. Now between 0 and 3, I marked positive. It says positive, yeah. The derivative is above the x-axis. Positive, yes. Finally, after hitting derivative 0 here, still positive above the x-axis. So we have positive here, negative here below the x-axis, positive here above the x-axis, and finally positive again above the x-axis. That'll give you plus, minus, plus, plus. And consequently, the original function is increasing, decreasing, increasing, and increasing. What happens to critical point when original function increases and decreases? That's local maximum. Decrease and increase, that's local minimum. Increase and keeps on increasing, neither maximum nor minimum. So this diagram completely answered part A and part B of the problem. Of course, you can write everything like this, increasing in negative infinity to negative 4, decreasing in negative 4 to 0, excuse me, negative infinity to negative 3, excuse me, I miscounted. 1, 2, 3, okay, negative 3, sorry about that. Local minimum at x equal to negative 3, that's local maximum, and local minimum at x equal to 0. Sorry, I miscounted. Somehow I wrote negative 4 here. Let's count again. This is 0, 1, 2, 3. Yes, at x equal to negative 3. This is correct. By the way, this diagram is really the correct diagram. By the way, let me show you the graph. The real graph looks like this. Increasing is the local maximum. Decreasing hits the local minimum. Increasing hits this critical point. Keeps on increasing. So this is neither maximum nor minimum. We have three critical points. X equal to 3, x equal to 0, x equal to negative 3, and these are neither minimum, maximum, or from the left, maximum, minimum, neither. Of course, I didn't ask you to sketch the original graph. You can answer everything from this diagram. And this diagram completely answers part A and part B, so I'll count this one as full credit and also a work. If you write like this only, without the diagram, I may take a couple of points off for the work. The same goes over here. Even though this is correct, I may take one or 2 points off if I don't see this kind of diagram. This diagram is really important in a sense that it's work and also it's justification, complete proof, and also complete answer. Okay, so much for part A and part B. How about part C and part D? We're going to answer that later after going back to the theory and discuss the concavity.